The last topic we have left is about climate change. So we've talked about a bunch of different um, environmental issues that are brought about by various human actions like pollution or species extinction, resource use, etc. So we'll move on to the last one, which is climate change. What do you know about climate change? Well, I guess it's an environmental issue that you've probably heard of. What's changing about our climate? What, Annabelle? What's that? Yeah, what about it? Yeah, the average global temperature of the Earth is rising. And it's rising because of human activities. Do you know what human activities contribute to climate change?
Greenhouse gases.
Yeah. Do you know what greenhouse gases are? Like what's the most what greenhouse gas is being emitted by humans in huge amounts since the Industrial Revolution? Yeah, carbon dioxide. So we'll talk about some of those. So yes, climate change is humans impacting the overall climate of the Earth. And it's because Ryan mentioned this term greenhouse gases. We'll talk about that in a second. One of them is carbon dioxide. If we look at this graph, well, I'll let you finish writing so you can look at this. If we look at, we can determine the past level of carbon dioxide in the atmosphere in a whole bunch of different ways. And when we look at that over the last 400,000 years, carbon dioxide levels in the atmosphere have gone down, they've gone up, they've gone down, they've gone up, sort of in a pretty regular pattern. You may know that in the Earth's history, there have been ice ages. These are periods when the climate of the Earth was much colder than it is today. Those are these bottom valleys that you see here. When carbon dioxide levels dipped, that's when the Earth experienced ice ages. But if you look at more recent times, if you look at here, so we had this rise, dip, and so forth. But then we get to sort of modern times. And the cycle sort of stopped. And now we see that we're all the way up here in terms of carbon dioxide levels in the atmosphere. And there's a reason for that. In, the 1800s, humans started to burn coal and then eventually oil and natural gas to produce electricity, to run industries and factories and so forth. And when we burn fossil fuels, we dig coal out of the ground and burn it to power a factory to generate electricity. One of the byproducts of that is carbon dioxide. And so for the last 200 or so years, we've been digging these fossil fuels out of the ground, burning them in our cars, in factories and power plants, etc. And all of that carbon dioxide going into the atmosphere has been building up. And so the levels of carbon dioxide are much, much higher than they have been for a very long period of time. And carbon dioxide has an important effect on the temperature of the Earth. Carbon dioxide traps heat in the atmosphere. It happens, Ryan mentioned the greenhouse effect, or he mentioned greenhouse gases. A greenhouse gas in our atmosphere it's mostly nitrogen, but there are also gases such as carbon dioxide and methane and other gases that trap heat. When we look at sort of a model of the Earth, the heat of the Earth comes from the sun, basically. Sun shines on the Earth, and the Earth absorbs a lot of that energy. And then it reflects that energy and releases it back into our atmosphere. These gases that are in our atmosphere trap some of that heat. Carbon dioxide is one of those gases. It's important that we have carbon dioxide and other greenhouse gases in our atmosphere. If we didn't, the Earth would be much colder than it is and maybe not able to support the life that it does. So greenhouse gases are important, but we are adding more of these gases to the atmosphere. It's almost like putting more blankets on your bed, right? Blankets trap your heat from your body so that you stay warm. That's what a blanket does. You put on more and more blankets, you trap more and more heat, and you stay warmer. Same sort of principles working in the atmosphere. These special gases trap heat. If we add more of these gases, we trap more heat, and the overall temperature of the Earth increases. So how much is the Earth's atmosphere increasing? Well, there's various models that predict what will happen to the temperature of the Earth. Here's historically what's happened. We know this has happened already. So we see the red line you could look at is sort of the average. So the average temperature of the Earth since the Industrial Revolution is above what it normally is, right? About 0.4 degrees Celsius higher than normal. What's going to happen? It depends. What is going to happen in the future depends on lots of things. One important thing depends on what we do, because there's different scenarios. This graph kind of shows those various scenarios. We could do nothing and just keep burning fossil fuels at the rate we currently are. That's sort of the worst case scenario. That puts us at the greatest temperature change of almost 5 degrees Celsius. 5 degrees Celsius would be catastrophic for the planet, for ecosystems, for us. We'll talk about why in a minute. But there's other scenarios, right? There's scenarios where we do different things to try to address climate change. And depending on which of those scenarios we follow, we might hold our warming to like 1.5 or 2 degrees. That's not great, but it's better than 5 degrees or 4 degrees or 3 degrees. And so how do we address, what can humans do to limit our emissions of fossil fuel, of greenhouse gases? Like how can we shift from warming of 5 degrees to warming of 3 or 2 degrees? Do you know what some of the actions that can do that? Partially. So gasoline cars, which we call internal combustion engines, they use gasoline as their fuel source. And they emit, when they burn gasoline, they emit carbon dioxide. Transitioning to cars that use an alternate fuel source could be an important way, right? Cars add a large chunk of that carbon dioxide to the atmosphere. How we generate our electricity is another important one. What are some ways we can generate electricity without adding carbon dioxide to the atmosphere? Is there any other way to get electricity other than burning coal or natural gas? So solar panels, solar photovoltaics, take the sun's energy and directly generate electricity, but they don't have any carbon emissions when they're producing electricity. Wind turbines don't produce any carbon dioxide emissions, but they can still generate electricity. Nuclear power. Nuclear power plants generate electricity without emitting carbon dioxide. Hydroelectric power. So if we transition our energy use to more of those renewable sources, then we can reduce the amount of carbon dioxide we're releasing. So there's different scenarios depending on what actions humans take. The other important thing is that a single country, so different countries contribute to climate change in different amounts. Some countries produce huge amounts of release huge amounts of carbon dioxide, use huge amounts of energy. Other countries less so. But the carbon dioxide doesn't if the carbon dioxide emitted by the United States doesn't just like stay above the United States and cause the United States to be warmer, right? It travels throughout the atmosphere. This is a global issue. And so in many ways it takes global cooperation, countries to agree together to limit our use of fossil fuels. And so it takes cooperation. And there are different ways that countries have tried to do this. So what happens so let's talk about the warming of the earth. Because sometimes people want to say, well, it's only 1.5 or 2 degrees Celsius or 3 degrees Celsius. Doesn't seem like a lot when we just say the number. But it has a big impact on all sorts of different things. So we could talk about some of those. As the earth gets warmer, one thing that happens is the glaciers, polar ice caps melt, right? Because the earth is warmer, the North Pole, the South Pole, those areas are covered in ice currently. But as the earth warms, that ice starts to melt. And that does a couple things. One is it leads to a rise in sea level. Ice that's on top of land, as it melts, that water eventually ends up in the oceans. And that causes the level of oceans to rise. Obviously, an increase in sea level leads to flooding, right? Coastal areas can become flooded because sea level is rising. There are already lots of places that are experiencing this. Like, for example, Miami. If you've ever been to Florida, you'll know it's pretty flat in Florida. And so a small increase in sea level can actually flood large areas. The city of Miami is dealing with this. They are spending billions of dollars to install these pumps that will keep their streets from flooding. And lots of people like to live on the coasts. Like you think of lots of the cities you may visit, Boston or New York or Los Angeles, San Francisco, Baltimore, Miami. All of these are coastal cities. People tend to live on coasts. And so as those areas get flooded, that has impacts on people living there, on the ecosystems there. Some small island nations basically are under threat of being completely submerged. As temperature increases, the ocean temperature increases. And that temperature of the ocean, the heat energy in our oceans, is what provides the energy for storms. Tropical storms, hurricanes, things like that. So as the earth becomes warmer, it means there's likely going to be more intense storms like hurricanes. Ecosystems will change. We know that in certain areas, the climate determines what type of ecosystem there is. Right? We have a hardwood forest in our area because of our temperature and moisture. Well, if our climate changes, that can lead to a change in which species are able to survive in those areas. Some species may not be able to deal with warmer temperatures. Most ecosystems will shift northward. Ecosystems like the tundra will be reduced over time because it's going to be too warm to support those species that are adapted to that area. Migration of animals, patterns will change. Forest fires will likely increase, and so forth. And so all of these changes to ecosystems may come about as the climate changes. And many of them already are coming about. One especially important issue is the melting of the polar ice caps, because when there's ice at the poles, ice reflects a lot of the incoming energy. But as that ice melts, the underlying land and sea absorbs more, and that causes more warming, which causes more melting, which absorbs more heat, which causes more warming. And it's sort of a positive feedback loop in which, as the ice melts, it becomes warmer, more ice melts, and that process repeats. We can see graphs if we look at the amount of ice there is at the North Pole. We have seen that it's decreasing in the past decades. And so this also affects humans. So it affects natural ecosystems, for example. It also affects humans in lots of different ways. It affects agriculture. There's large areas of the earth where conditions are becoming drier, okay, where there's drought, which means less ability to grow food, which can lead to famine and things like that. Flooding. When sea level rises, when storms become worse, then there's a greater risk of flooding in different areas, greater risk to human health due to these hurricanes. As conditions change, people are going to be forced out of their areas where they live. I just heard a piece of news that was about drought in Africa. And in certain parts of Africa, hundreds of thousands of people are leaving their homes because there's no food and are going to the cities to try to find sort of resources to support their families. And so you have people that will be leaving their homes because climate change has forced them out because they don't have enough food or water. Also, there are impacts on human health. The warmer the climate is, the more pollen plants produce, which impacts people with allergies. The warmer the climate gets, the more disease-causing insects can spread. One thing that will happen is, for example, ticks. I worked with somebody from Hamilton College, a professor who was researching the impacts of climate change in our area. And one of the biggest impacts is that the number of ticks that are found that spread Lyme disease is going to increase drastically. Heat waves can cause people to, can cause physiological stress on people. So what do we do? How do we address some of these issues? This is a general ways that we can address all of the environmental issues that we've been talking about. Population. We talked at the beginning of this unit that human population is a driver of many of these environmental issues. So if people become more educated, if there's more access to family planning resources like birth control, then we can limit population growth of the human population on the earth. Conserving resources by using things more wisely, reducing our use of the earth's resources, reusing and recycling products. Those things can help to reduce some of these problems. We can address pollution at a government level by taxing pollution, by encouraging companies, power plants, facilities to be more efficient in their use of resources. And there are examples of legislation, of laws and agreements between countries that have done this. We talked about ozone depletion. And countries came together in the 1980s, agreed to stop using as many chlorofluorocarbons, and that helped to reduce the ozone depletion problem. And as we talked about earlier, that the hole in the ozone layer is improving. And it's improving because countries came together and made agreements to try to address it. We could do the same for climate change or um, other problems. And you may hear of Paris Accords or the Paris Treaty. It was a major treaty that countries throughout the world signed to try to address climate change. But this word is underlined trade-offs. That's an important term. It's one that sometimes shows up on the Regents exam because doing some of these activities, we have to think about the trade-offs, right? If we put a tax on carbon emissions, for example, that can reduce climate change, but it may come at an increased cost of, for example, gasoline. If we are going to protect an endangered species, we may make it illegal to build or destroy their habitat, but that may mean there's less area for land development. So there's always these sort of positives and negatives, these costs and benefits. We call those things trade-offs. When we're trying to address problems, thinking about what those trade-offs are is an important part of the process. We have to look at that and make a decision as to the overall benefit of these various actions.